Welcome back to the Learning Studio. You're watching our mathematics series, where we explore the foundations of science, technology, and artificial intelligence. If this is your first time here, don't forget to follow us by clicking the link below. And remember, the full playlist is in the description, so you can catch up on all our previous episodes. Today, we're diving into one of the most futuristic and exciting areas of mathematics, quantum mathematics, the field that provides the framework for quantum mechanics and, more recently, quantum computing. Think about classical computers. They use bits, zeros and ones, to process information. But in the quantum world, we move beyond certainty into probability, superposition, and entanglement. To describe this strange universe, we need new mathematics. Mathematics that can handle infinite dimensions, uncertainty, and operators that behave in non-intuitive ways. This is where quantum mathematics comes in. Core concepts explained simply. Here are the essentials. Hilbert spaces. Imagine an infinite dimensional version of Euclidean space. Hilbert spaces provide the stage where quantum states live and evolve. Linear operators. In quantum theory, operators represent physical actions, like measuring energy or changing spin. They're the mathematical tools that transform quantum states. Superposition and probability. Instead of a single outcome, quantum states are combinations of possibilities. Hilbert space mathematics tells us how to calculate probabilities of different outcomes. Unitary transformations. These preserve probability and describe how quantum states evolve over time. They are the foundation of quantum algorithms. Quantum computing. Here, mathematics isn't just describing nature. It's being used to design machines. Quantum algorithms like Shor's for factoring large numbers and Grover's for faster searching rely directly on Hilbert spaces and linear operators. Why it matters in AI, computing, and technology. Quantum mathematics isn't just futuristic theory, it's shaping the next revolution. In quantum computing, it underpins every algorithm, from cryptography breaking techniques to powerful optimization. In physics, it provides the rigorous foundation for understanding the quantum world. In AI, researchers are exploring quantum-inspired models for faster computation and better learning. In cybersecurity, the rise of quantum algorithms is forcing us to rethink cryptographic systems, pushing forward the development of post-quantum security. It's the mathematics that will determine how the next generation of computers will think and process information. So, quantum mathematics gives us the tools to step into the weird and wonderful world of quantum mechanics and computing. It's not just abstract, it's the foundation of technologies that could redefine computation, security, and artificial intelligence. In our next episode, we'll turn to combinatorics, the mathematics of counting, arrangements, and complexity. From analyzing algorithms to optimizing searches, combinatorics lies at the heart of computer science and problem solving. Don't forget to follow us by clicking the link below and check out the full playlist in the description. Each episode brings us closer to seeing how mathematics shapes not just the past, but the very future of technology.